I'm going to tell you about a project we've been working on here at the University of Dundee. Is building an image data repository. It's been a BBSRC funded project that's been a collaboration with EuroBioImaging. I've also been working with EuroBioImaging project for some time now, so various URLs that are involved in this project are shown here on the slide. So the open microscopy environment, which is building a lot of technology that sits underneath this application. The URL is openmicroscopy.org, EuroBioImaging URL, and I tweet from J.R. Swedlow. So, and obviously, feel free to make comments on the presentation on Twitter or wherever. Okay, so EuroBioImaging is, like ELIXIR, an S3 infrastructure project and aspires to deliver image data services across all the domains of biological and medical imaging for scientists in the European Union. And this slide kind of highlights all of the different aspects of the services that EuroBioImaging aims to provide for the European community. So obviously that's the imaging technologies themselves, as well as training, sharing expertise, best practice, highlighting innovation, networking, all of the different domains across biological and medical imaging. And for the purposes of today, certainly mechanisms for accessing tools for analysis and data storage. So you can think of what we're going to talk about today as one component of the EuroBioImaging project, obviously one critical component for the community, but it is admittedly just one part of that. So this slide sort of highlights the same concepts, but in a different way. So EuroBioImaging is a distributed infrastructure with a hub that links to a whole series of technology nodes. Those nodes will be providing either single sort of technologies or perhaps many different technologies for the community. It highlights, in these bullet points, the key point is that there will be access to cutting-edge imaging technologies across the EU. There will be support for data and critically training for users and providers. The key point of all of this is that this is really an open infrastructure, so all of these capabilities and technologies will be openly available to all European scientists. Slide highlights how we think any scientist in the European Union would access the EuroBioImaging technology. There's a central web access portal which is being built now, which any scientist could connect to, identify the technologies that EuroBioImaging provides, identify the sites where those technologies exist, make contact, and either connect to or even go and visit those sites that providing that imaging technology, perform all of the necessary data management and analysis for the imaging that they do, and then ultimately be able to publish that data. So, this is obviously a highly simplified version of a very complex infrastructure, but this is the aspiration. The EuroBioImaging is actually moving quite well. The project is in the so-called interim phase. It's gone through a very successful preparatory phase in the middle of a process of defining various governance and legal architectures and moving towards operation probably at the beginning of 2017. Several countries are driving this interim phase. You see them listed there. This is a process by which both scientists and funders and representatives from scientific ministries all have to come together to make all of this happen. So it's to be fair, it's a combination of both a scientific, legal, and a financial and a political enterprise. But And if you want to find out where all that is, I encourage you to visit the EuroBioImaging website. Summary of an awful lot of work is that, in fact, this is moving quite well. One of the most exciting things about EuroBioImaging is that it has brought together a large number, or I guess catalyzed the formation of national imaging efforts in many of the European member states. So you see sort of a summary there. But in many cases, actually, that has resulted in the appearance of imaging for the biological and the biomedical sciences appearing on the national strategy documents and the national roadmaps of several countries. That's critically important for taking all of this forward. I have to say this is an achievement that's been driven, possibly inspired by EuroBioImaging, but driven by the scientists in each of these member countries. So an enormous number of people have participated in all this. EuroBioImaging, during its prep phase, ran several proof of concept projects, and one of them was to test this idea that infrastructures or basic, potential nodes would make available their technology, and then scientists from other sites and even other countries might visit. And in this, we were trying to establish the demand for making these capabilities available. This map, so we ran basically a 6-month trial, and this map sort of shows the different visits and different technology tests, in some sense, that happened during that phase. And it was actually pretty impressive. So we have an enormous amount of experience and data that demonstrates the need for this kind of infrastructure. Now let's focus on the data services that EuroBioImaging aims to provide. And so, as I said, this is just one component of the EuroBioImaging infrastructure. But it really comes down to 2 specific services. The one I won't talk about today is the tool repository. So this is a resource that European scientists could access, identify the tools, the software tools, the analytic packages, and so on that are appropriate to use for their imaging problems. And so it's through a lot of surveys, et cetera, we've seen that it's very important to catalyze the connection between scientists who are actually doing the experiments and the analysis tools and the platform that are available. And so that's something I won't talk about today, but it's a very important part of the project. What I will talk about is this idea of building data repositories. So we want to be able to provide services and systems for hosting data collected within EuroBioImaging, specifically reference data sets, and I will talk about what that means, but you'll see that phrase a couple times in this presentation, the idea of reference image data sets that should be shared and reused by the community. And so, in fact, these aren't just sort of high-level concepts of the, for example, PowerPoint slides that you're seeing, but in fact, we've been actually doing work towards this, and there was a pilot project that's now being taken forward, a separate project. And actually, what I'm really going to tell you about today is a pilot project that's been funded in the United Kingdom with funding from the BBSRC, and tell you where we've got to at that point. So why would we actually want to share data? And I'm going to just feed you a couple quotes that many of you have seen. This is a quote from a report from the Royal Society that basically journals should enforce requirements for traceable and usable data. And many of you have seen this. Another one from the Wellcome Trust. This is basically policies that are being said to its funded scientists. The EU has published several guidance documents on this. One I think that's probably most useful is a document called Riding the Wave. Many of you have seen that, where it really highlights the need for all of this. But every time people start talking about sharing data, they highlight genomics and maybe proteomics, but imaging is always held out to be something that's extremely difficult and possibly something that is just so hard to solve that no one ever will. So why is that? And so these are, on the slide, some of the reasons. We have large images, some numbers are given there. Perhaps the most challenging of all of this is that, in fact, imaging is not just one type of data. It's an incredibly heterogeneous domain with lots of different types of data, and a few of them are listed there. And each of these, so any of the specialists in any of these domains would immediately tell you that, inside magnetic resonance imaging, there are lots of different subdomains that are in fact different, and you can do that for every one of these. And so it's extremely complex and heterogeneous. Any of the data are acquired as a part of a specific experiment. So in imaging, we don't yet have, for example, a comprehensive collection of all data. There are a few examples of that, both in biological and medical imaging. But just as an example, I'm going to show you some data sets today that are combining genetic and RNAi and chemical and geographic perturbations or sampling. And there are many, many others, obviously, across diseases, populations, et cetera. So it's a really complex space, and to collect all of those, to specify and collect all of the metadata around all of these different types of studies is extremely challenging. Let's face it, today we don't really have complete standards for the various metadata. I think it would be hard to argue that we could collect and specify, collect, and somehow integrate all of the metadata. But the hope is I'm going to show you some examples. But just as some examples of what we would have to deal with, you sort of see some examples there. There's a lot of different heterogeneity there. And I'll just say that those of us who have been doing this for some time, when you receive data from any individual study, and here I probably have to be careful with what I say, but the fact is that the data aren't always well annotated. There are desperate needs for curation and intervention to clean up to the data to make it as consistent as possible. And even if we did all of those dealt with all of the bullet points, the first, whatever it is, 5 or 6 bullet points here, the last one is probably a really confounding one. So there's so much data out there. Which of those data sets should be published? We know that in science we don't publish our notebooks. So a paper doesn't include everything we've ever done. And so there's no requirement, I think, to publish all data, but which are the data sets to publish? None of these, that's kind of an open question. So there's a lot of challenges here that we have to solve. So what I'm going to do in the next few slides is suggest some potential, I want to say, partial solutions. So these types of challenges are held up as a reason that we don't know anything to do about imaging. And what I'm going to suggest is that while we don't have the complete answers yet, we do have some solutions that we can use to move these challenges forward a little bit and start building essentially not solutions, but maybe proofs of concept that hopefully can lay the foundation for future work. So in EuroBioImaging, for example, we did a lot of, in the EuroBioImaging prep phase, we did a lot of surveys, we did proofs of concepts, etc. And so, all of this data is actually published on EuroBioImaging.eu, and you can see all this. But the bottom line is that as we move into construction of EuroBioImaging, depending on the size of the number of nodes and the number of users, we actually have pretty good estimates for the amount of data that we're going to generate and the amount of data that should, in fact, be moved into some kind of common repository, and thus, storage requirements, etc. So, in fact, we have some real numbers that we can use as guidelines for taking all of this forward. Again, all of this is published, and if you're interested in more detail, I refer you to the EuroBioImaging website. So what about metadata standards? And so this is still quite tenuous, but the fact is that, in practice, when we started collecting data sets, we see what are effectively de facto standards that people end up being used, which come down to some kind of tab-delimited formats. Those are spreadsheets, those are isotab, those are whatever, but in fact, we have lots of these examples now. And in fact, most of these can be linked out to resources that, projects like ELIXIR already run. And so, the external linkage to more defined resources, there are things that we can use. And so, while not a complete solution here, there definitely is pretty good resources and standardization for us to at least get a start. On the imaging metadata itself, the project that I've been leading for some time, the Open Microscopy Environment Project, we have the OMA data model. We have bioformats, which is a software library that converts the proprietary image file formats into that common data model. It reads light microscopy, electron microscopy, digital pathology, high content screening, medical imaging data. And we have a data management application called Amero, which can provide platform-independent APIs for images and metadata. So while not a complete solution, we do have some of the tools we need. Again, I can't tell you, I'll refer you to external resources, openmicroscopy.org can tell you more about that. Now, one of the challenges in any of these, in any imaging problem is that almost all imaging leads to some sort of downstream analysis to take all of the pixel data and turn it into some sort of measurements. And again, in practice, what we see is that most scientists end up using some kind of tabulative data format. Again, a CSV, TSV, whatever. Alternatively, there are some examples now of these data being stored in HDF5 files. So, again, this is not standardization, but it's at least, a fairly limited set of formats which we can try to support. And in fact, bioformats and Amero, combinations of those can read these formats, okay? So, with that, we think we have some idea of taking at least a proof of concept forward without having to wait for full standardization. And okay, what about which images to publish? So, as I said, the EuroBioImaging proof of concept studies, we know that way less than 10% of the images we're going to record are really publishable. And in fact, ELIXIR and EuroBioImaging a couple of years ago spent some time working through these concepts. I refer you to a document you can find if you sort of search on that phrase in the slide there, EuroBioImaging ELIXIR Image Data Strategy, you'll find the document. And I think the idea is that, there's obviously in ELIXIR, there's an enormous amount of biomolecular data, and that's terrific. And in EuroBioImaging, we imagine that there will be a large number of images, and those will be terrific as well. And there'll be some kind of subset of both where it makes sense to try to build linkages between them. And so, we have some idea of the volume, and we have some idea of the types of data that we use to link across these two projects. In particular, sort of systematic studies looking at either structural imaging, cellular imaging, model organism imaging, human atlases, and so on. And so with this, this provides some guidance going forward in terms of what kind of images that we think we will need. This isn't the full story, but at least it's a reasonable start. So based on all of that, I think it's reasonable to suppose that we could try to build some kind of architecture. But I think it's worth thinking about why we would even do that in the first place. So, this slide highlights one idea around ways of using imaging and image data repositories. So at the bottom here, it's taken for granted, and I think obviously a common aspect of our daily lives, and I assume almost everybody on this call, that we work with gene level similarity kind of all the time. This is the basis for much of modern biology. And that we know that works quite well. There are several groups that have worked out ways to define phenotypic similarity, almost always by some kind of ontological representation of a phenotype, and we know that that works as well. And so, the gene ontology and various other ontologies as well can be used to connect data from different studies and to communicate that either in human form or actually machine-readable form that can be used for statistical analysis. So building on top of those two concepts, we imagine that if we could reduce or convert the imaging data in multiple studies into some kind of quantitative feature set, and by this, for example, that you take this thumbnail and decompose it into a series of polynomials that represent in some way the structure of this image, and you do the same with, for example, images in another data set and all other data sets. An open question is, can we start to find similarities in terms of the structure and dynamics and components of images and start to build similarity tools that would deliver some measurements of similarity in the same way that we now routinely do, say, for gene level similarity. That's a proposition, and we don't have the answer to that yet, but that's the basis for what we're trying to do. So the proof of concept we've been building, this image data repository, I'm going to show you some examples of this in a second. This has been just a really fun collaboration with Albus Prasma at EBI and Rafael Carrazzo-Salas at Cambridge. As I said, BBSRC has funded this, and you see some screenshots there. Currently, we have 12 published papers with 16 screens, variety of different organisms are represented, different structures. A reasonable amount of data and a reasonable number of images have now all been integrated, and importantly, we have, basically as well as possible, connected all the experimental, the analytic, and the phenotypic metadata into a single resource. And in progress, I would say we're looking to bring in other data sets as well, and you see some of the ones that we're going after at the moment. And if any of you have data sets or know of data sets you think should be included, please do get in touch with us. We'd be happy to discuss that with you. And I think Gabriella Rosticci, who's on the call, would be more than happy to pursue sourcing those data sets and getting them into this resource. Okay, so some examples of the resource. So you see the URL there, idrdemo.openmicroscopy.org. See the sort of basic statistics, series of screens. So in any of these screens, this is one of them opened up. We have all the thumbnails, and for every image, we have all of the imaging metadata, the experimental metadata, and also the phenotypic analysis, and all of that's available. I should say that the user interface for this is plain Amero as it comes out of the Open Microscopy project. Has not at all been customized yet for the kind of repository application that we will ultimately want to be building. Again, it's a proof of concept. All of this data is available in this web UI, but also obviously through the API can be queried. A couple other examples. So we've been fortunate enough to get data from Luis Pedro Coelho and Eric Arcenti at ENDL. And these are images from the TARA data set, so the TARA Oceans data set, which is a global sampling of plankton in the world's oceans. And here we've included obviously all of the images, but also all the navigational metadata, depth metadata, etc. And you can browse that. You can browse that resource as well. Now, there's a lot of other studies, and what I've done is just to put up on the slide a few sort of shortened URLs that will get you to various views of various data sets in the that are published in the IDR as of today. I'll leave the slide up. Also, I think Nicole is going to publish a PDF of the slides, and so you can grab those URLs from there. More than welcome to use them for what they're worth. Just a few highlights, obviously several different examples. You saw the TARA data set as well. The MIDACHEC data set is in there, which is a human phenotypic screen of mitosis from time-lapse sequences. Recently published paper from Michael Boutros and Wolfgang Huber's labs. There's a chemical screen. There's a DOI for that, so we now have the ability to issue DOIs for these studies as well. And so all of that's there. So just moving on, trying to finish up. So does anybody care about this? And so I just wanted to put up a quote, and this is kind of interesting. So we started sending emails out to the community mentioning, kind of trying to publicize the IDR. And pretty soon after we put this out on various lists, I got this from one of the top scientists at one of the large pharmas. And so I thought this was very interesting because to hear what they were thinking about, what this individual was thinking about in terms of how these resources could be used, and really gets the concept of data reuse. And so I won't read through all of the text here, you can see it, but clearly what they're thinking about is combining lots of different studies for the functional predictions and compound activity for their chemical libraries. And clearly they need large numbers of data sets, and I think the key in many machine learning applications is the generation and the integration of many of these resources. So this is great to see, and hopefully we can take that forward. So where are we going with all this, and how will we make this truly accessible? So the first thing we want to do is, and this is ongoing, this is what we're doing now, and I guess, in terms of the activities we're doing, besides trying to get more data into the system, so we've got lots of different studies, as I mentioned, trying to take these through a comprehensive calculation of all features, that I think reasonably that anybody would ever calculate, at least in the first instance, combine all of those quantitative features from all of the images in the IDR with the various types of metadata that we have, as well as the thumbnails, and put all of that together either into a sort of a single data download or some kind of container or image on some kind of cloud and make that available. And so we hope to have that available over the next couple months, and the team here in Dundee is working hard on getting these calculations done. So the idea there is that we would make all of the metadata portable, downloadable, and available for the community to do whatever they wanted with. Okay. Now, obviously, making all the metadata available is terrific, but we're not, and maybe I should just emphasize, just in case there was any doubt, we will ship the image thumbnails, but we will not ship the image data itself. And in many cases, the thumbnails are okay, but there are several time-lapse screens, etc., in which the thumbnails do not at all represent the underlying data. So, how is it that we would make all of the image data available for reanalysis? And it's just not going to be practical to be downloading, tens of terabytes of data. We know that doesn't work. And so what we're working towards in a collaboration with the MBL is to make the IDR available on their embassy system. And so, again, a prototype. But the idea is this would be a virtualized system that external users could attach to, perform their calculations on using a variety of tools that we'll make available, things like, for example, MATLAB, Python scripts, Cell Profiler, etc. A variety of different open source tools that can be deployed on this system for reanalysis of the data. And all of that hopefully will be made available over 2016. So, just to go back to this slide that I showed you, I focused really on the right side of the slide, but I hope you would agree that, we've made some progress, that this isn't just, sort of whiteboard PowerPoint ideas, that there actually is some real technical progress. By no means do we have all the solutions in place. By no means have we supported all of the different imaging modalities that will need to be supported in the fullness of time, but I hope we've made some progress in this direction. So just to finish up, huge thanks to everybody who's been involved in this project. And, as I said, it's been a long-term sort of collaboration with EuroBioImaging, and several people there have been very important for this. The people in the OME team who have been working extremely hard to deliver everything you saw that I've shown you today. Nice collaboration, as I mentioned, with Alvis Brasman's group, Rafael Carrazzo-Salas' group, and a huge thanks to BDSRC for the funding, and in particular Rowan McKibben and John Hancock, who really made all of this happen. And we would be nowhere without lots of different data submissions from many different individuals, so huge thanks to them. And finally, a big thanks to the funders. Money makes a huge difference in this business, and be able to have the resources to do something like this has been just fabulous. So that's it. I guess I will switch out of the presentation. I'm happy to answer any questions.